Okay, we're going to work problem 16, and I have three algebraic fractions that I'm multiplying. As you can figure out by now, what you want to do is simplify each one, factor each one of these expressions before you go. I'm going to go pretty fast as I factor these. What I would recommend you do is pause the video, see if you can factor each of these expressions yourself, and then turn the video back on and see if you've got the same thing that I got, and go from there. So you might want to pause the video and give yourself a moment to do this. First numerator is going to factor 2, x and x. Two numbers that multiply to give me negative 6, add to give me negative 5 would be negative 6 and positive 1. Negative 6 times 1 gives me my negative 6. Negative 6x plus 1x is my negative 5x. I have x and x for the first terms here. Two numbers that multiply to give me positive 4, that add together give me negative 5. It's got to be negative 1 and negative 4. Next fraction, x squared minus x minus 12, the x and x. Two numbers that multiply to give me negative 12, add together to give me negative x, give me minus 4, and plus 3 gives me my negative x for the middle term. This binomial, all you can do is factor x squared out of each term, so do so. Leaving you with x squared times x minus 6. Likewise, with this binomial, factor an x out of each term. Now, if I do that, I'm going to do that off to the side for a moment. If I factor an x out of each term, I end up with 1 minus x squared inside the parentheses. Again, x times these gives me the x minus x cubed. But 1 minus x squared is the difference of two squares. It'll factor to 1 plus x, 1 minus x. So I'm going to go ahead and do that factorization as well, because that is the full factorization of x minus x cubed. Then finally in the denominator, I'll have x. Two numbers that multiply to give me positive 1, add together to give me negative 2, would be minus 1 and minus 1. Let me approach the camera for just a second to make sure that I haven't cut us off. We can still see that right-hand side. Okay, I think we're good to go. Now, I'm going to have a wealth of common factors that'll cancel. I've got an x minus 4 and an x minus 4. I have an x minus 6 and an x minus 6. This x and this x squared will cancel and leave me with an x. Now, I have a slight problem here in that I have an x minus 1 and a 1 minus x, or actually I have three factors of x minus 1. That 1 minus x, it doesn't look the same. It doesn't look like a common factor. But there is a numeric trick that you can do to make it work. I'm gonna write what I have so far, and then I'll show you that trick. I've got an x plus 1 in the numerator, and x plus 3. X plus 1 or 1 plus x, it's again the same thing, and 1 minus x. All over x minus 1 times, usually if you have an x, you put it first. This factor of x times x minus 1 times x minus 1 times x minus 1. Now, there is a trick that you can use here to solve the problem. I have 1 minus x. If I had x minus 1, I could cancel it. Here's what you do. You take 1 minus x and you factor a negative 1 out of it. If I do that, that would give me negative 1 plus x. But wouldn't the opposite, that would be the same thing as x minus 1. You see this often enough when you do problems like this that it eventually gets to be just automatic. If you have a difference and it's in the wrong order from a factor you can cancel somewhere, reverse the order of this distance, this difference, write that as x minus 1 and put a negative sign out in front. I take that negative sign and put it out here. So now this x minus 1 and this x minus 1 will cancel. And I'm left with x plus, the opposite of x plus 1 times x plus 1 times x plus 3 over x times x minus 1 times x minus 1. I'm a little short on board space here, so let me do one last thing to simplify this. You can always back the video up if you need to see some of that again. But it is not uncommon. X plus 1 times x plus 1, you could write that as x plus 1 squared, and that'd be fine. And x minus 1 times x minus 1, you could write that as x minus 1 squared. This may be the answer you see in the back of the book, or they may just leave it like this. It's two ways to say the same thing. Either one would be fine. And that's problem 16.